Okay, so we're recording. Solving square root and other radical equations. I'd say about 85, 90% or more of what you're going to be solving will be square root equations. Okay. A radical equation has a variable in the radicand or a variable with a rational exponent. So either you're going to have it underneath the radical, either a cube root or a square root or whatever, and a variable is inside the radical. Or, as we did the other day, you can rewrite the radical as a rational exponent. The square root of x is equal to x to the 1/2 power. Those are also radical equations. Equation doesn't just mean as a square root. It means that the variable is part of that square root, or cube root, or fourth root. Okay. Square root equation is one where you have a square root involved. That's what most of the ones we're going to do are square roots. Extraneous solutions. This is one of the important parts of the extraneous solution. Let's say that of this first set of notes. Extraneous solutions are solutions you get when solving that don't actually work in the original equation. Every step you did to solve for x, to get x equals some value, is a legitimate algebraic mathematical step to solve the equation. You did everything properly. But that answer does not work in the original problem. You must check your work in the original problem. An extraneous solution is one that doesn't work. It is entirely possible there is no solution. You solve the problem, you get a number, it doesn't work, nothing works. Okay, or you might get more than one answer, in which case one works and another one doesn't. We have those situations a little bit when we were doing absolute value problems. They will happen here a lot more often. Most extraneous solutions come in two types: in radical equations and rational equations, which is where you have a variable in your denominator. You have a function that has a fraction, and the denominator contains the variable. You're not allowed to have zero. You'll often get extraneous solutions that will give you zero because you get zero in the denominator in your original problem. So what you must do when you solve your equation, take the answer you get, x equals, y equals, whatever, plug it back into the original problem. Does it work? If it works in the original problem, everything's great. If it doesn't work in the original problem, then that's an extraneous solution and it doesn't work, and you may have those solutions if that's the only one you got. But you have to check every answer, and you need to check it in the original equation. And it's really, the way I do it, the way I expect you to do is mentally plug it in and work it out. Okay, you don't have to write it out and do all the math. You can just plug it in into your head, figure out what it is. Okay? So, very simple today, that there's only one real topic that we're going to do, but I'm going to do several examples to show you all the possibilities that will arise as you're doing these, because they're all the same idea, but okay, so this one's here and that one's there. They're all a little different in one shape or another, but they're all the same basic thing. Okay, but a lot of examples today. I know, there's only 2 on this page, but trust me, there's a lot of examples, okay, because I left room to work. Okay. Solve and check for extraneous solutions. I need to solve the problem. Your first step, and it's already done here, if you have a square root equation, get the square root by itself, everything else on the other side of the equal sign. Then I need to remove the square root. To get rid of the square root, you do its inverse. You square both sides. When we had square x, when we solved problems where we had x squared, what did we do? We took the square root of x. Okay, that was one of the things we did, was using the square root of both sides. It works the same way. I square both sides. So I square this side, and I square that side. You square both sides. When you square a square root, you get what's underneath. When you square a square root, that's all you're doing is just getting rid of it. So the square root of 2x plus 1 squared is 2x plus 1 equals -3 squared, which is 9. And now solve this equation for x. Subtract 1, 2x equals 8. Divide by 2. X equals 4. There's my answer. What do I have to do every time? I have to check my answer to make sure it works. So I take 4, I plug it into the original equation. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. 3 does not equal negative 3. No bueno. No solution. That is an extraneous solution. Everything we did, every step we did was good and valid. What it means is there is no answer. There is nothing that will work. Okay? Next problem. Little different. This one I had square root equals stuff. That one, I don't have square root equals stuff. I need to get square root equals stuff. So I have to solve for the square root of x first and then square both sides. Subtract 6. 4 root x equals negative 2. Divide both sides by 4. Square root of x equals negative 1/2. So I get the square root by itself first, and then I square both sides. Square that, and I get x equals 1/4. 1/2 squared is 1/4. Negative 1/2 squared is 1/4. Put in 1/4 into the problem. Take this, plug it in and check it. Square root of 1/4 is 1/2. 1/2 times 4 is 2. 6 plus 2 is not 4. 6 plus 2 is 8. Once again, no solution. Our answer does not work. It is an extraneous solution. Every step we did was valid math, valid algebra. Our final answer doesn't work in the original problem. That means nothing will work. And if you stop and look at the problem, think about it. The square root of a number will be positive. 4 times a positive number will be at least 4, right? 6 plus 4, or something larger than 4, will never be equal to 4. So nothing would have worked, and you could have looked at the problem. I still want you to do all the work, even if you say, even if you look at the problem, say, nothing's going to work, Mr. Orris. Do the problem and prove it. Okay. What do they always say when they want you to solve? Whenever you want to make a point, do the math. Well, do the math. Okay, same idea. Square both sides. This one's an easy one. Okay. X plus 5 equals 64. Subtract 5. X equals 59. And try it in the original problem. 59 plus 5 is 64. The square root of 64 is 8. We're good this time. Oh, crap. Second one's not a square root. I can't square both sides to solve this. What do I need to do? What do I do? What do I do? I cube both sides. Thank you very much. Yeah, so what if it's not a square root? It's a cube root. Fine, cube it instead. Okay, cube both sides. X plus 4 equals 8. Subtract 4. Yeah, 2 cubed is 8. Subtract 4. X equals 4. Oh, it's a square root. I don't have to check my answers, right? No, you still got to check your answers. 4 plus 4 is 8. Cube root of 8 is 2. So we're batting 50%, right? On whether or not the answers work. More examples. Oh, no. Oh, no. What do I do first on this one? Divide both sides by 3. I want my square root by itself first. Divide by 3. And I get the square root of 2x plus 1 equals 2. And now I square both sides. Square, square. 2x plus 1 equals 4. 2x equals 3. X equals 3/2. And then I still have to try it in the original problem, see if it works. 2 times 3 over 2 is 3. 3 plus 1 is 4. Square root of 4 is 2. 2 times 3 is 6. We're good. Uh-oh. I can't get square root equal to everything that's not a square root when I have 2 radicals in there. This is as complicated as it gets with 2 radicals for you guys. There are other possibilities. You will not get them with 2 radicals. If I have a square root equal to a square root, I obviously cannot solve for a square root by itself. So here's what I do. I just square both sides. Just square both sides. 7x minus 6 equals 5x plus 2. These are tricky ones. Often they work and you get a good solution. Often extraneous solutions do pop up on these. You really have to be careful with them. So 5x from both sides. And I get 2x minus 6 equals 2. Add 6 to both sides. 2x equals 8. Divide by 2 and x equals 4. And I have to try 4 in both sides of the equation to make sure it works. 4 times 7 is 28. 28 minus 6 is 22. So on this side of the equation, I have the square root of 22. 4 times 5 is 2 plus 2 is 22. I have the square root of 22 equal to the square root of 22. I am not pulling out a calculator to see what the square root of 22 is on my calculator. I can't simplify it, so I don't care. But if I get down to the square root of a number equal to the square root of the same number, obviously they're equal to each other. And it does work. The problem you have to watch out for sometimes when you have a problem like this is that underneath one of them you end up with the negative square root. You end up with the negative underneath the square root on one side and the positive underneath on the other side. That's generally when you have where it's not equal or negatives on both sides. Okay, these are the ones that are going to get nasty on you in a hurry. These are the ones you're going to watch. Once again, my first step is to get the square root by itself. So on this first equation, I'm going to subtract 4 from both sides. And I get x minus 4 equals the square root of 2x. Now here is the tricky part, or the first of 2 tricky parts in problems like these. I square both sides. X minus 4 squared, the square root of 2x squared. Remember, x minus 4 squared is not x squared minus 4 squared, is it? You cannot distribute squaring across subtraction. It's x minus 4 times x minus 4. There is a middle term. You need to FOIL it out. Now remember, there is a shortcut for squaring. There is a shortcut for squaring. So if I want to do my shortcut, square the first term. What do I get when I square my first term? X squared. Multiply the 2. What's x times negative 4? Negative 4x. Double it. Negative 8x. Double it. Minus 8x. Square the last term. I take negative 4 and square it. I get 16 plus 16 equals 2x. Now, if you don't want to do that, just instead do x minus 4 times x minus 4. Combine up like terms, and you'll get the same thing in the middle. Either way is okay with me. I don't really care. Okay? Does that make sense? Do you see that? Now I have a quadratic, and I have to solve a quadratic. Oh my God, we haven't solved quadratic since last semester, but that was also. To solve a quadratic, my first step is to set it equal to 0. Subtract 2x from both sides. X squared minus 10x plus 16 is equal to 0. Remember how to do this? Two numbers that multiply to give me 16. Then when I add them together, I get negative 10. 8 and 2, but they're both, yeah, -2, -8. Okay. So that means I get x minus 2 times x minus 8 equals 0. So x minus 2 equals 0, x minus 8 equals 0, which means x equals 2, x equals 8. Scroll back so we can see the original problem. Yeah, this is about as bad as it gets. Get over it. Okay. No struggle, no growth. No challenge, no growth. And it's not; these are not things that we haven't done before. It's just been a little while since we've done them. We did these. Chapter 4, I believe, was solving these. Okay. So what do? We have to check it, our answer in the original problem. So I plug in 2. 2 times x is 2 times 2 is 4. Square root of 4 is 2. 4 plus 2 is 6. 2 does not equal 6. That one doesn't work. Plug in 8. 2 times 8 is 16. Square root of 16 is 4. 4 plus 4 is 8. Usually, but not always, you have to check. Usually, when you have this situation where you get a quadratic in there, you get 2 answers, and one works, the other one doesn't. Usually. Sometimes both work, sometimes neither one of them works. I'd say about 80% of the time or so, one does, one doesn't. But you have to check to know which one, and if you get one that doesn't work or does, do not assume that the other one is exactly the opposite, because they might both or might not. Okay? Do another one of these together. Same idea. Your first step is to add 5 to both sides. Square root of x plus 7 equals x plus 5. Now I have square root by itself, so I square both sides. Square that. Square that. I get x plus 7 equals x squared plus 10x plus 25. Square the first, multiply the 2, double it, square the last. And I have to be equal to what? 0. Subtract x, subtract 7, and I get 0 equals x squared plus 9x plus 18. Two numbers that multiply to give me 18 that add to give me 9. 3 and 6, and they're both positive, 3 and 6. So I get 0 equals x plus 3, x plus 6. So x plus 3 equals 0, x plus 6 equals 0. So x equals -3, and x equals -6. Now, I know what you're thinking. You're thinking, oh, they're both negative. How can something with a square root be equal to a negative? Well, remember, we got the -5 in there. That might make a difference, so we do have to check them both. And it's okay to put a negative underneath. It might not be positive when you're done. So, for example, I take -3. -3 plus 7 is 4. Square root of 4 is 2. 2 minus 5 equals -3. That one's good. Put -6 in there. -6 plus 7 is 1. Square root of 1 is 1. 1 minus 5 is -4. No, doesn't work. Like I said, usually one does and one does not, but there's no guarantees. Okay? Questions? Your turn. Okay, most of you are finished, so let's go ahead and do these. So the first one, square both sides. 2d minus 5 equals 7. add 5, 2d equals 12, divided by 2, d equals 6. And I tried in the original equation. What? Oh, thank you. Oops, my bad. Okay. Thank you, thank you, thank you, thank you. 49, is that better? Okay. Add 5 to both sides, I get 54. Divide that by 2, I get 27. That's a little better. So I take 27 and plug it in. 2 times 27 is 54. 54 minus 5 is 49. Square root of 49 is 7. So this is good. Right. Second one. Subtract 2 from both sides first. Square root of 4c plus 3 equals 3. Square both sides. 4c plus 3 equals 9. Subtract 3 from both sides. 4c equals 6. Divide by 4c equals 6/4, which is actually 3/2. Always reduce. 4 times 3/2 is 6. 6 plus 3 is 9. Square root of 9 is 3. 3 plus 2 is 5. That's our answer. Okay. Next one. What question? No. Did I screw up again?
No, she actually got the 6. I said we subtracted the 3. Yeah.
Subtracted 3. Okay. That's okay. Just making sure. Cube both sides because it's a cube root. 2m minus 4 equals 27, right? 3 cubed, 3, 9, 20, yeah, 27. Add 4 to both sides. 2m equals 31. Divide by 2, m equals 31 over 2. And then I want to try it. 31 divided by 2 times 2 is 31. 31 minus 4 is 27. Cube root of 27 is 3. We're good. And usually if it's a square root equal to a number, just a square root equal to a number, they almost always work. You rarely get, unless it's equal to a negative, you rarely get extraneous solutions. And if it's equal to a negative, it's not going to work anyway, so why bother? Because square root equal to a negative, it's not going to work. Square root equal to 0 could work, though. Because if I get 0 underneath, the square root of 0 is 0. These next two are a little more complicated. Let me give myself a little more room. Still not that bad. Square root equal to a square root. I square both sides. 5y plus 5 equals 7y minus 1. Subtract 5y. And I get 5 equals 2y minus 1. Add 1. 6 equals 2y. Divide by 2. Y equals 3. 3 times 5 is 15. 15 plus 5 is 20. 3 times 7 is 21. 21 minus 1 is 20. Square root of 20 equals square root of 20. 3 is good. And then the next one. The complicated one. I have to get the square root by itself first, so I subtract 6. Square root of x equals x minus 6. Once I get there, I square both sides. Square, square, x equals x squared minus 12x plus 36. First term squared, multiply them and double, square the last term. To solve, I need to set it equal to 0, so I subtract x from both sides. 0 equals x squared minus 13x plus 36. And then two numbers that multiply to give me 36 that add to give me negative 13. 9 and 4. Negative 9, negative 4. 0 equals x minus 4, x minus 9. So x minus 4 equals 0, x minus 9 equals 0, x equals 4, x equals 9. And then I try them. 4. Square root of 4 is 2. 2 plus 6 does not equal 4. This one's no good. Second one, 9. Square root of 9 is 3. 3 plus 6 is 9. That one's bitty good. Bitty good. That's it. Short, quick, easy. Isn't it all? Wouldn't all